Hi, kids!
Hi, Uncle Ben!
It's time to play Know Your Numbers!
Yay!
Are you ready?
Yes!
Here we go with our first number. What number is that?
3.
Yes, it's 3 in the ones place. We sometimes call that the units place. 3 ones. Now, what number is it?
53.
Yes, 5 tens and 3 ones. 53. What number is that?
653.
6 hundreds, 5 tens, 3 ones. 653. In some countries and in some languages, they might say 50 and 3, but we'll just say 53. And in some places, they might say 653, but we'll just say 653. What number do we have now?
4,653.
Yes, the 4 is in the thousands place. And when we get to the thousands place, we put in a comma. We do that after 1, 2, 3 places. This comma tells us that we say the word thousand. 4,653. In some countries, they don't use a comma. They use a period. So if they do that in your country, you'll just have to adapt a little bit to follow along with what we're doing. But we have a comma there. What number do we have now?
24,653.
And what number do we have now?
724,653.
When you see a number like this, first you read whatever this number is before the thousand comma. Then you say the word thousand, and then you read the rest of the number. So you see in front of this comma the number 724, and that's what you say. 724,653. Now what number do we have?
8,724,653.
Now we've moved over another 3 places. 1, 2, 3. So we need to separate it with another comma. This comma is our million comma. And we say whatever number comes in front of that, and then we say million. So we say 8,724,653. What number do we have now?
18,724,653.
First we say the 18, then we say million, where the comma is. What number do we have now?
918,724,653.
And what number do we have now?
3,918,724,653.
Now we've moved over another 3 places, so we have to separate our numbers with another comma. This comma right here. And that's known as the billions comma. Now in some countries, they don't say the word billion when they have a number that large. They would say 3,918 million, and then continue to read the rest of the number. But most countries do it like this, and we're going to do it this way and say the word billion. 3 billion. Read the rest of the number again. 3 billion.
918,724,653.
Would you like to see what that looks like if we write it out in words?
Yes.
Here it is. 3,918,724,653. Notice that when you have a number like 24 or 53, you put those 2 words together with a hyphen. Sometimes when you see a number written in words, you'll see it without any commas in it, just like this. But sometimes they will have put the commas in for you. I'll do it now. 3,918,724,653. Okay, let's do some more numbers. What number is this?
2.
Yes, and we write it like that. What number is this?
402.
Yes, 4 in the hundreds place, 2 in the ones place, but there is nothing in the tens place, and we have to fill that place with a 0. So we have 402. What number is that?
70,402.
Yes, you see the number 70 right before the thousand comma. So you read 70,402. The 7 is in the 10,000 place because 70,000 means 7 10,000s. There is nothing in the thousands place, so we have to fill that place with a 0. Let's see how that looks if we write it out in words. 70,402. Now, Suppose I come along and I erase this 4. I have to fill that space with something, so I put in a 0. What is that number now?
70,002.
Yes, it's just 70,002. We no longer have the 400 that was there before. So let's cross out the 400. And now we just say 70,002. What number is this?
$300,012.
Yes, the number that we see before the 1,000 comma is 300. So we say 300,000, and then all we have is 12. When we write it, it looks like this. 300,012. Let's try one more number. Four. Four, 0, 7, 0, 0, 2, 0, 2, 7. Let's read that number.
407,002,027.
Look at all the spaces that we had to fill with zeros. 1, 2, 3, 4 spaces that were filled with zeros. And if those zeros aren't there, the number would be read some other way. But here's how it looks if you write it out. 407,002,027. Okay, this time we're going to start by having the number already written out in words, and then we're going to see if we can actually write the numeral. What is our first number?
7.
7, and we'll write it like this. It's just a 7 in the ones place. Now let's do our second number.
34.
34. 3 10s, 4 1s, 34. $512. 500, 1 10, and 2 1s. 512. $
706.
706. 7 in the hundreds place and 6 in the ones place. 7 hundreds and 6 ones. Now, what should I put in the tens place?
A 0.
A 0. If we had not put that 0 in the tens place, what number would we have?
76.
It would just be 76 with a big hole in the middle. So we have to make it 706.
8,321.
8,321. 2 tens, 1 1. 8,321.
9,017.
9,017. 9 thousands 17, which is 1 10 and 7 ones. What do I have to put in the hundreds place?
A 0.
A 0. Now it's 9,017.
60,002.
60,002. The number I have to put in front of the 1,000 comma is 60. And I have to use 2 places to do it. 60,000. 60,000. And the rest of the number is just 2. We have to fill these 2 places with a 0. 60,002.
$500,000.
The number that we see before the 1,000 is 500. To write 500 before this 1,000 comma, we need 3 places. 500,000, and all the rest is zeros. Notice that the 5 is in the hundred thousands place.
$2,304,017.
2,304,017. 2,304,017.
$8,001,001.
8,001,001. The number before the word billion was 8. The number before the word thousand was 1. It didn't tell us anything before the word million. 8,000,001,001. What do we have to put in every one of those other places?
A 0.
0, 0, 0, 0, 0, 0, 0. 8,001,001. So now, do you know your numbers?
Yes!
Once again, it's time to play Know Your Numbers! Are you ready?
Yes!
All right. We already know that this is the ones place, the tens place, the hundreds place, and the thousands place. Now, what do we have if we have 10 ones?
Tens.
And what do we have if we have 10 tens?
100.
And what do we have if we have 10 hundreds?
1,000.
So 1 times 10 is?
10.
Times 10 is?
100.
Times 10 is?
1,000.
Now let's do it in the other direction, and this time we'll divide. 1,000 divided by 10 is?
100.
And 100 divided by 10 is?
10.
And 10 divided by 10 is?
1.
And 1 divided by 10 is?
1/10.
Yes, 1/10. And that's why we call this the tenths place. 1/10 divided by 10. Well, let's find out. 1/10 divided by 10. What do we do with this 10?
Put it over 1.
Now, if we're going to divide, we have to change it to multiplication. We keep the 1/10, we change it to multiplication, and what do we do with the 10 over 1?
Turn it upside down.
We flip it upside down. Now let's multiply across. 1 times 1 is?
1.
10 times 10 is?
100.
Therefore, 1/10 divided by 10 is 1/100th. And we could show that 1/100th divided by 10 is 1/1000ths. So these places over here are the tenths place, the hundredths place, the thousandth place, and even the 10,000ths place. This one we say hundreds, but this one we say hundredths. There's a THS at the end. This little point right here is called the decimal point. And all the numbers that we write on these places to the right of the decimal point, we call decimals. Now, decimal means 10. Deci means 10. And our number system is based upon tens. That's why one place is 10 times more than the one next to it. Well, let's put a number right here in the tenths place. What shall we call that number?
4/10.
Yes. First, we say the number, then we say the name of the place where that number ends. This number begins and ends right here in the tenths place. So we say 4/10. Let's see how we'd write that in words. 4/10. Everybody read it.
4/10.
Now we're going to put an 8 in the hundredths place. When we read a decimal number, first we read the number, then we read the place where the number ends. Well, what's the number?
48.
And what's the place where the number ends?
Hundredths.
So the whole thing is
48 hundredths.
48 hundredths. And this is how it looks if we write it. 48 hundredths. Now we'll put a 9 in the next place, which is the thousandths place. First, read the number, then read the place where the number ended. Let's say the whole thing all at once. What is this decimal number?
489 thousandths.
Yes, and here's the way it looks when we write it in words. Read it.
489 thousandths.
Now we're going to put in one more number in the 10 thousandths place. Read this decimal number.
4,893 10,000ths.
And here's the way it looks when we write it. 4,893 10,000ths. Now I'm going to put some numbers on the other side of the decimal point. 7, 5, 6, 2. When we have a decimal point and a number in front of it, we have a special way of reading that decimal point. All we have to do is say the word "and." The decimal point is read "and." So, what is this entire number?
7,562 and 4,893 10,000ths.
Very good. And here's how it looks when it's written out. 7,562
and 4,893 10,000ths.
Now we're going to write some more decimal numbers. Remember, first you read the number, then you read the place where the number ended. What's that number?
8 hundredths.
First we read the 8, then we read the hundredths. Because that 8 is not in the tenths place, it's in the hundredths place, and we had to fill the empty space with a 0. 8 hundredths. How about that one?
25 thousandths.
Yes, the number was 25, and the place where it ended was the thousandths place. 25 thousandths. There's another one.
4 thousandths.
4 thousandths, and we had to put zeros in the tenths and in the hundredths places. Read that one.
324 ten thousandths.
Yes, the number was 324. The place where it ended was the 10 thousandths place, and there was a 0 in the tenths place. If we write it out in words, it looks like this. Read that.
324 ten thousandths.
Yes, 324 ten thousandths. Read that one.
56 ten thousandths.
56 ten thousandths. Read that one.
9 ten thousandths.
9 in the 10 thousandths place, and 3 other places are each filled with zeros. Let's do one more. All right, read that one.
78 and 307 thousandths.
Yes, 78 and 307 thousandths. Tell me now, what number is in the tenths place?
30.
What number is in the tens place?
7.
What number is in the hundredths place?
0.
And what number is in the ones place?
8.
All right, do you know your numbers?
Yes.
Let's do some more. Now we're going to start with the number written out in words, and we'll see if we can write the numeral. So here's the first one.
4 tenths.
4 tenths. We'll just put a 4 in the tenths place, and that will give us 4 tenths.
86 hundredths.
86 hundredths. We have to write the number 86, and it has to end in the hundredths place. It has to end here, and we'll just put the 8 right in front of it. 86 hundredths.
Three 317 thousandths.
We have to write the number 317, and it has to end in the thousandths place. Here's the thousandths place. It has to end here, and the 3 and the 1 just go right in front of it. 317 thousandths.
Three hundredths.
3 hundredths. We'll write the number 3 in the hundredths place. Are we finished?
No.
We have to fill the tenths place with a 0, or otherwise there'll only be one number to the right of the decimal point, and it would have been 3/10 instead of 3 hundredths. So we fill that empty space with a 0.
Forty-two thousandths.
42 thousandths. We write the number 42. It ends in the thousandths place, and we fill the empty space with the 0.
One thousandth.
1 thousandths. All we have to do is put the 1 in the thousandths place and fill the other 2 places with 0.
Five hundred 22 ten thousandths.
522 ten thousandths. We begin the number 522 there so that it will end in the 10 thousandths place. And then we put a 0 in the empty tens place. 522 ten thousandths.
Seven hundred 17 and 71 thousand.
717 and 71 thousandths. The 717 goes on this side of our decimal point, and the rest of it says 71 thousandths. We'll have to put it there so that it ends in the thousandths place and fill the empty place. Now let's read it back for ourselves.
717 and 71 thousandths.
Very good.
Three 3,004 and 5/10.
3,004 and 5/10. 3 thousands, 4 ones, and 5/10. We have to fill these 2 empty places with zeros. Let's read it back again. 3,004 and 5/10. So we have just 2 more numbers to do. Where'd it go? Our chart. It's gone. Well, we'll just have to do without it, and then we'll really find out if you know your numbers.
Yay!
Here's our first number.
86,050,007.
86,050,007. Well, let's put our decimal point right there. We're going to have to go all the way over for 86 million. There's our 1,000 comma, 1, 2, 3 places, and our million comma, and 1, 2 places. 86 million. We can put our 86 right here in front of the million comma. Then it says 50,000. We can put the 50 right in front of the 1,000 comma. Then it says and 7,000ths. Well, the and is right here. That's the decimal point. We have a number that has to be in the thousandths place. Tenths, hundredths, thousandths. 7,000ths. Have we done it?
No.
Is it finished?
No.
They say no. What's missing?
Zero.
Zeros. Let's put them in. 1 here, 1 here, 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 and here. Now let's look at our number and read it back to ourselves and see if we did it right.
86,050,007.
Very good. All right, we'll do one more. Let's read it.
9,016,004 and 410 3/10,000.
What a mouthful. That's a lot of number. We'll have to do that a little bit at a time or we'll get marbles in our mouth. All right, it says 9 million. We'll have to start with a million comma. Billion. See, I got marbles in my mouth already. 9 billion. Well, this was the million comma. We're going to have to give ourselves a little more space. 3 places, and then the billion comma, and then we can put our 9 right there in front of the billion comma. Here's our 9. 9 billion. Let's go back and see what it says next. 9 billion 16,000. 16,000. Should I put my 16 right here?
No.
No, because this is the million comma. We have to put that 16 right in front of the comma that's for thousands. 16,000. Let's see what else it says. 9,016,004. Well, we know where to put the 4. That's just 4 ones. What else? And
403 10,000.
we have to write the number 403, and it has to end in the 10,000th place. Well, we have tenths, hundredths, thousandths, and just enough room for 10,000ths. And the number is
403 10,000.
403, ending in the 10,000th place. And now we have to fill all the empty places with
0.
0, 0, 0, 0, 0, 0, 0. Please read it back to me just by looking at what we've written.
9,016,403 10,000.
Well, I'm convinced it's true. You really do know your numbers. Now we're going to learn how to change a fraction into a decimal. Suppose I have a fraction like this. What does that fraction say?
3 tenths.
As long as you can read the fraction, and since you know how to read decimals, you should be able to convert that to a decimal. You know it says 3 tenths. All we have to do is write 3 tenths. How many places after the decimal point do I need to fill for tenths? 1. So I can put the 3 right there in the first place because we know that that is the 10th place. This is read 3 tenths, and this is read 3 tenths. They are exactly the same. Now read this one.
17 hundredths.
How many decimal places do I need for that?
2.
Just 2. And I can fit my 17 right in those 2 places. 17 hundredths. And read that one.
452,000.
How many places do I need for that one?
3.
3 places. And I can fit in that the 4, the 5, and the 2. Did I forget something?
Yes.
What did I forget?
The decimal point.
And it goes right here. And read that one.
500ths.
How many decimal places do I need for hundredths?
2.
And I have to put the 5 so that it is in the hundredths place. Therefore, I have to fill this space with a 0. 5 hundredths as a fraction, 5 hundredths as a decimal. Read that one.
67 thousandths.
How many places?
3.
And it has to end in the third place, so I have to put a 0 in front. 67 thousandths. And this one. What does it say?
3 thousandths.
How many places?
3.
And the 3 goes in the last place because it's 3 thousandths. As we read this decimal back to ourselves, first we read the number, which is 3, then we read the place where that number ended, the thousandths place, and we get 3 thousandths. And let's read that one.
1,598 thousandths.
How many decimal places?
4.
0.1598. When I say 0.1598, I like to say that that's the way I spell it. But if I ask you to read it, what would you say?
1,598 ten thousandths.
And another one. And let's read that.
237 ten thousandths.
How many places?
4.
It has to end in the fourth place, and so we fill the tenths place with a 0. And let's read that one.
18 ten thousandths.
How many places?
4.
The 18 has to end in the fourth place. We have to fill 2 places with a 0. 18 ten thousandths.
One ten thousandths.
How many decimal places?
4.
0.0001. And we've learned how to change a fraction into a decimal when that fraction has a bottom number of 10, 100, 1,000, or 10,000. Now we're going to change a decimal into a fraction. The first one is 0.7. How would you read that?
7/10.
And all you have to do is write the fraction that you said when you read the decimal. And you said 7/10. Next one, 0.6. Read that one.
6/10.
So I write 6/10. But I'm not satisfied with that as my final answer. Why not?
Need to reduce it.
We're going to reduce it. What can I hit both the 6 and the 10 with?
2.
2 into 6 is,
3.
and 2 into 10 is,
5.
so 6/10 as a decimal has become 3/5 as a fraction. The next one is 0.93. Read that.
93 hundredths.
And all I have to do is write 93 hundredths. Can it be reduced?
No.
No, it cannot. Point 72. Read that one.
72 hundredths.
72 hundredths. What would you like me to hit it with to reduce it? Any ideas? Question. Are both top and bottom numbers even numbers?
Yes.
And if they're even, that means that we can divide them evenly by what?
2.
So we can do that. What is 2 into 72? Well, we can do that division. And we will see that it does come out evenly as 36. And it should be very easy to know what happens when we divide 2 into 100. What do we get?
50.
50, because if you have 100 in 2 pieces, each one is 50. 36 fiftieths. Is it finished?
No.
What can we hit it with now?
2.
We can hit it again with 2. 2 into 50. Well, what's half of 50?
25.
25. That's something we should know. 2 into 36, we might not know, so we'll do the division, and we see that it comes out to be 18. Is it finished?
Yes.
Yes, it is. It cannot be reduced any more. Now, it so happens that first we hit it with 2, and then we hit it with 2 again. We did it in 2 steps. Does anybody know what number we could have used if we wanted to do it in 1 step?
4.
4, because 2 times 2 is 4. 4 into 72 would have given us 18, and 4 into 100 would have given us 25. But it's fine that we did it in 2 steps, by 2, and then by 2 again. 0.367. Read that.
367 thousandths.
And I'll just write what you said. 367 thousandths. And I think you'll find that that one is already in lowest terms. Here's another. 265. Read that one.
265 thousandths.
Can it be reduced?
Yes.
What can we hit them with?
5.
5. We'll have to divide 5 into 265. 5 into 26 goes 5 times, using 25, giving you 1 remainder, and bring down the 5. 5 into 15 goes 3 times, and it's come out evenly. Our top number is 53. Now we have to divide 5 into 1,000. But we can do that the short way. We see that the 5 will go into 10 how many times?
2.
If it were 100, instead of 2, it would be
20.
And since it's 1,000, instead of 20, it's going to be 200. 5 into 10 is 2, and 0, and 0. 53 over 200. Point 09. Read that.
9 hundredths.
9 hundredths. Can that be reduced?
No.
No, it's already in lowest terms. Point 08. Read that.
8 hundredths.
8 hundredths. What can we hit that with to reduce it?
4.
Some say 2, some say 4. Yes, we can hit it with 2 because both top and bottom are even numbers. But we can also use 4. We know that 4 goes into 8 how many times?
2.
And we should also know that 4 goes into 100 how many times?
25.
So 25 times 4 being 100 is something that you should memorize so that you'll know that 4 into 100 is 25 times, and 25 into 100 is 4 times. Point 083. Read that.
83 thousandths.
83 thousandths. And I think we can see that that one is already in lowest terms. Point 036. Read that.
36 thousandths.
36 thousandths. Can that be reduced?
Yes.
What would you like to hit it with?
6. 2.
Some say 6, some say 2, some say, I think I heard 4. Well, we know we can do 2 because they both end in even numbers. We know that the 6 can go into the 36, but I'm not so sure about the 1,000. I know that 36 is also on the 4 table, and I know that 4 can go into 1,000 because I just did that and because I know that it will go into 100. So let's try 4. How many 4s are there in 36?
9.
9. It's right on your times table. How many 4s are there in 25? Excuse me. How many 4s are there in 100? 25. So I gave you the answer. There are 25 4s in 100. So in 1,000 there are 250. We just add another 0. 0.001. Read that.
1,000.
1,000th. Okay, 1,000th. Can it be reduced?
No.
No, it can't. It's already been done. Point 004. What does that say?
4 thousandths.
4 thousandths. Can it be reduced?
Yes.
What would you like to hit them with?
4.
Sure. 4 into 4 is 1. 4 into the 100 is 25. So into the 1,000 is?
250.
Very good. 0.175. Read that.
175 thousandths.
175 thousandths. Can it be reduced?
Yes.
Now, from the fact that we see that we have a 5 and a 0 as ending numbers, what do we know that we can hit it with?
5.
So we know we can hit it with 5. However, there's something else that we can see there. When numbers end with 25, 50, 75, or double 0, like in 100, 200, 300, or in any number of hundreds, we see that they can be divided by 25. How many 25s in 125? 1. That question answered itself. How many 25s in 50?
2.
How many 25s in 75?
3.
How many 25s in 100?
4.
So that's a piece of useful information, to be able to count by 25s up to 100. Well, let's divide 25 into 175. I think we could try, we would normally try 8 if we took off these two numbers and said 2 into 17 is 8, so we'll try it, and we'll find out it's a little too big. 5 times 8 is?
40.
Carry the 4. 2 times 8 is?
16.
Plus 4?
20.
20. Well, that's too big. Let's try 7. 25 times 7. 5 times 7?
35.
35. Carry the 3. 2 times 7 is?
14.
Plus 3?
17.
There we have our 175. 25 into 175 was?
7.
25 into 100 is?
4.
So into 1,000 is?
40.
40. And this reduces to 7/40ths with a little bit of work. .0375. Read that number.
375 10,000.
Yes, 375 10,000ths. What shall we use to reduce that one?
25.
Yes, because we see that it ends again in 75 and double zero. Well, we'll have to divide 25 into 375. 25 into 375. Well, it goes into 37. How many times?
1.
1 times 25 is 25. We subtract, get 12, and we bring down the 5. How many do you think we can fit in 125?
5.
I think 5 is a good one, and you would find that it does come out just right. If you had tried 6, you would have found out it was just a little too big. So we have 25 into 375 is 15. 25 into 100 is?
4.
And then?
40.
And then?
400.
400. Is it finished?
No.
What would you like to hit it with this time?
5.
5 into 15 is?
3.
5 into 40 is?
8.
So into 400 is?
80.
80. So that's a nice trick, being able to cover up this 0 and then uncovering it to get your final answer. So 375 10,000ths reduces to 3/80ths. Now we have another new times fact that we want you to memorize. It's very helpful to know that 125 times 8 equals what we're going to find out. Let's do the work and find out for sure. 5 times 8 is?
40.
Put down the 0. Carry the 4. 2 times 8 is?
16.
Plus 4.
90.
Put down the 0. Carry the 2. 1 times 8 is?
8.
Plus 2 is?
10.
It equals 1,000. 125 times 8 equals 1,000. It would be very good for you to memorize that. Then, if I ask you 1,000 divided by 125, you should immediately know what to tell me. What would be the answer?
8.
Of course. If 125 times 8 equals 1,000, there are 8 125s in 1,000. Suppose I asked you what 10,000 divided by 8 is equal to. Well, let's just first look at it as 1,000. How many 8s in 1,000?
125.
And the extra 0 makes it 125 with an extra 0. So knowing that 125 times 8 is 1,000, can come in handy when these numbers come up, and they come up very often when you're working with decimals. Now we have another little helpful trick about dividing by 25. Now we already know one way to do this one. We know that 25 into 100 is how many?
4.
And the extra 0 makes it
40.
But this 1,000 is also 10 100s. How many 25s are there in one 100?
4.
Okay, there are 4 25s in one 100. So how many would there be in 10 100s? 40. And there we have our 40. And that becomes more helpful when you work with numbers like this. Suppose I had a fraction and the numerator was 200 and I wanted to divide it by 25. I say, how many 25s in 100?
4.
So how many in 200?
8.
Because there's 4 in each one of those hundreds. So there are 8 in 200. How about 225 divided by 25? Well, how many 25s are there in 200?
8.
And how many in the 25?
1.
1 in the 25, 8 in the 200. How many altogether?
9.
Very good. Now you're catching on. 625 divided by 25. How many 25s in 600?
24.
24, because there's 4 in each 100, and you have 600, so you have 6 times 4 of them. There are 24 in 600, and how many in here?
1.
And 24 plus the 1 makes 25. So this is a little trick for dividing by 25 when you have a number that 25 will go into evenly. How about 350 divided by 25? How many 25s in 300?
12.
3 4s make 12. And how many in the 50?
2.
So the 12 of them plus the 2 of them makes how many of them?
14.
14. And we'll just do one more. 975 divided by 25. How many 25s in 900?
36.
9 times 4 is 36. And how many in the 75?
3.
Plus 3 more makes 39. 36 plus 3 more, 39. 975 divided by 25 is 39. Instead of being 975, if we had one more 25, it would be 1,000, and then instead of 39, we would have 40. So that's a little trick. If you can learn it and use it, it will help you to be able to divide those numbers by 25 in your head without having to do a big, long division problem. And very often when you're working with decimals and reducing fractions that come from decimals, you'll find yourself needing to be able to divide by 25, and that's a helpful trick. Sometimes you need to be able to look at two different numbers, decimal numbers, and be able to tell which one is the larger. For example, 0.3 or 0.30. First thing we should do is read them. What does this one say?
3/10.
And what does this one say?
30/100.
Which one do you think is the larger?
30/100.
30/100, they say. Some say, no, no. What do the no people say? They're the same. Well, let's look. Didn't we once say that if we had 30/100ths and we wanted to reduce it to lowest terms, we could divide both top and bottom by 10 by taking off the zeros?
Yes.
And what do we have left?
3/10.
Which is the same as that. So they are the same. So you say, Uncle Dan, you mean that 0.3 is the same as 0.30? And I say, yes, they are absolutely equal. And they're also equal to that, that, or 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 that. Okay? You are allowed to add a 0 on the end of a decimal without changing its value. And sometimes it helps to do that, because it was difficult to compare 3/10 and 30/100ths. But if we had found some way to make them so that they both were to the same place, or so that they both were like fractions with the same bottom number, or like fractions, we could have compared them. Well, we just found out that it's okay to add a 0 onto the end of a fraction, onto the end of a decimal. So let's add one here. This 0 does not change the value of this. Now tell me which one is bigger.
They're the same.
Same.
They're not only the same, they look the same. It makes it really easy. So we'll put a circle around both of them. If I ask you to circle the larger one, you'll circle, in this case, both of them. Let's do another. 0.3 or 0.31. Which is the larger?
31.
0.31.
0.31, everybody says. Well, my answer is, I don't know. Because one is tenths and one is hundredths. And I want them to both be the same. So I'm going to make this one hundredths also. Now let's read them. What does this one say?
30/100ths.
And what does this one say?
31/100ths.
So now you can say with some confidence that 31/100ths is larger than 30/100ths. But not until you put this 0 there to help you. How about 0.04 or 0.041? Is there any place that I should add a 0 to help me?
Yes.
What should I put it after?
The 4.
The 4. Yes, right here. Now we can see that this one is bigger. Read this number.
41,000.
41. First you read the number, then you read the place that you had to go to read that number. The end of that number. 41 thousandths is larger than what?
40,000.
Than 40 thousandths. Point 0.02 or 0.018. Is there one that I should add a 0 to help me?
Yes.
Where would you like to put it?
After 0 and 2.
All right, we'll put it after the 2. Read this one.
20,000.
Read this one.
18,000.
Which is bigger?
20,000.
20 thousandths is the larger. 0.0275 or 0.03. Let's read these two numbers first. What's this number?
275 10,000s.
And what's this number?
300s.
Well, those sound very different to me. It's very hard to compare them. Would it help if I added some zeros on the end of one of them?
Yes.
Where shall I put them?
After the 3.
How many zeros would you like me to add?
2.
If I add 2, then I'm comparing two decimals, each that use 4 places. Now all I have to do is look at the numbers themselves. This number says 275. This number says 300. Which is larger?
300.
So this is the larger. And as a decimal, we would read it as 300 10,000ths. But in the original form that was given to us, it is what? 3 hundredths, because the 3 is in the hundredths place. 0.999 or 1.001. Which is the larger of those two numbers?
1.001.
You mean this number that has only ones and zeros is bigger than this one with all those nice big nines in it?
Yes.
Nines are bigger than ones and zeros. Well, read me this number.
999,000.
Thousandths. 999 thousandths. Read me this number.
1,000.
Mishmash.
1,000.
Thank you.
1,000.
1 and 1,000ths, which I could write like this if you like. Seems you're not that well prepared at reading decimals just quite yet. So it takes a little practice, doesn't it?
Yes.
Well, is this one here more or less than one whole pizza pie? Less. This is a pizza pie cut in 1,000 pieces, and you got to eat 999 of them, and there was one little one left for Uncle Dan. All right? You didn't get to eat quite the whole thing. How about this? 1 and 1,000th. Is that bigger or smaller than 1?
Bigger.
Bigger.
This is 1 and a little bit, and this is a little bit less than 1. So when you're comparing these kinds of numbers, it helps to first look at what's on this side of the decimal point, in the whole number side. This is 1 and something. And even though the and something is a very little something, you still have 1. Here you have a very big something, but it's still less than 1. So this one is definitely the larger. 1 and a little bit more. Well, which is larger, 1.25 or 1.255? Place your bets.
1.255.
You are correct. First of all, we look and see that they are both 1 and something. 1 and something. So we'll have to compare the somethings. We see that this one has 2 decimal places and this one has 3 decimal places, so we'd better add a 0 so we can compare them more easily. And then we can see that 250 is less than 255, so you were all right. This is the larger. Point for 2 or 2.4. Which is the larger?
2.4.
But this is 42 and this is 24, Uncle Dan. So 42 is bigger than 24, so I think this one is the larger one. No? No, because this is 42 hundredths. It's less than 1. And this is 2 and something. This one is much larger. I couldn't fool you on that one. Can I fool you on this one? 23.2 or 2.39? Which is larger?
23.2.
But Uncle Dan, this is 232 and this is 239 and 239 is bigger than 232. No. You mean it matters where the decimal point is? This little point is important?
Yes.
This says 2 and something, but this says 23 and something, and you were all right that that one is the larger. $1.99 or 1.009. Which is the larger?
1.99.
What should I do to find out for sure?
Put a 0 on the 9.
Right here. They are both 1 and something, so we'll have to see which something is larger. This is 1 and, read the rest of it.
990,000.
Yes. And this is
1 and 9,000.
yes, well, 990 thousandths is a lot bigger than just 9 thousandths. So you were all correct. .08 or 0.080. Which is the larger?
They're both the same.
They're both the same, because if I add a 0 here, I can see they're absolutely identical. Now remember, if you have something like 8/10, you may add a 0 here, and here, and here, and here, but don't go moving over your decimal point and trying to add zeros on this side in between your number and the decimal point, because then you'll get a totally different number. You're only allowed to add these zeros after the end of the number on this side. Now that we know how to compare two decimal numbers and see which is the larger, we have a whole series of 6 numbers, and we would like to put them in order from left to right and smallest to largest. The first thing we're going to ask ourselves, is there any number up there that is larger than 1?
Yes.
Is this one larger than 1?
No.
This one?
No.
This one?
Yes.
What number is that?
5 1/10.
Yes, that's 5 and something. Is this one larger than 1?
No.
This one?
No.
This one?
Yes.
Yes, that's 5. Now that number has no decimal point on it. If we were going to put a decimal point there without changing its value, where would we put it?
On the right.
Yes, on the right. I'm going to put a decimal point right there, and I'm going to add a 0. Now it says 5 0/10. This one says 5 1/10. Which is larger?
5 1/10.
We'll put that one all the way over here on the right, and this one just before it because it's a little bit smaller. And we'll put it there the way it first came to us without the decimal point. Now we can cross off this number and this number from our list because we've used them already. Now let's look at our other 4 numbers. Is there one of them that doesn't have 2 decimal places?
Yes.
And which one is that?
5/10.
5/10. All the other ones have 2 decimal places. What can we do for this one so that will have 2 decimal places as well?
Add a 0.
We'll add a 0. Let's read these numbers and see which is the larger. This one is how many hundredths?
51.
And how many hundredths is this?
50.
And this?
5.
And this?
55.
Of those 4 numbers, which is the largest?
55 hundredths.
So we'll put that here. 55 hundredths. And which is the next smaller than that?
51 hundredths.
51 hundredths. And the next smaller than that?
50 hundredths.
50 hundredths. But we'll put that in the original form that we had it without the 0 that we added. And we have only one left, and which one is it?
5 hundredths.
0.05. And now we have succeeded in putting them in order from smallest to largest. We started working with the larger one, which sometimes is easier, and when we finished writing them, we had them in perfect order, smallest to largest. Here's another set of 6 numbers for us to put in order from smallest to largest. Are there any numbers there that are more than 1?
Yes.
This one?
No.
This one?
Yes.
Read that one.
3 6/10.
This one?
Yes.
Read that one.
6 3/10.
This one?
No.
This one?
No.
This one?
Yes.
So these 3 are larger than 1. This one is 3 and something, 6 and something, 3 and something. Which is the largest one?
6 3/10.
Yes. 6 and 3/10. Let's cross that one off because we've used it. Now we have 2 others that are larger than 3. 3 and something. How many decimal places does this one have?
3.
And how many decimal places does this one have?
1.
What shall we do to this one to make it like the other?
Add 2 zeros.
Add 2 zeros. 1 and 2. Now read it.
3 600,000.
And this one,
3 36,000.
which is the larger?
3 600,000.
So we'll write that one next. 3 6/10 was the way it was before we added the zeros. Now we'll cross off this one and this one. Let's look at the rest of our numbers. How many decimal places in this one?
2.
And in this one?
2.
And in this one?
2.
Well, we forgot to write this other one. We knew about this one, that it was larger than this one, but we haven't written down this one here. 3.036. Now, we've just said that each of the other 3 that we have left each have 2 decimal places. Do we need to add any zeros to make them alike?
No.
Let's just read them.
63 hundredths. 3 hundredths. 6 hundredths.
Which one of those is the most hundredths?
63 hundredths.
63 hundredths. Now we only have 2 more left. Which is larger, 3 hundredths or 6 hundredths?
6 hundredths.
0.06, 6 hundredths. And then the smallest one, 0.03, 3 hundredths. And now we've put all of those in perfect order from smallest to largest. And here's one more set of 6 numbers to put in order from smallest to largest. Are any of these numbers larger than 1?
Yes.
Are any of these any of these numbers not larger than 1?
No.
So they're all that way. Now, let's look at them. This one is 7 and something, 8 and something, 8 and something, 7 and something, 7 and something, another 7 and something. So the larger ones are the ones that have an 8 in the front, 8 and something. Let's look at the two of those, this one and this one. In order to compare them, what should we put at the end of this one?
A 0.
A 0. Then they'll have the same number of decimal places filled in the part of the number that's to the right of the decimal point. Read this one.
8 and 70 hundredths.
And read this one.
8 and 7 hundredths.
Which is the larger of those two numbers?
8 and 70 hundredths.
And we'll just write 8.7 because that's the way it was before we added the 0. And the other one is 8.07. And we can cross off those two because we've already used them. All the other ones are 7 and something, but they do not all contain the same number of decimal places. What shall we add to the ends of some of them to make them all the same?
Zeros.
And how many zeros should we add to this one?
2.
To make it go out to the thousandths place. 2 zeros. And to this one.
1.
And to this one.
2.
And now we will be able to compare them. How many thousandths are in this number?
800.
And in this number?
8.
And in this number?
780.
And in this one?
700.
Of those numbers you just read, which is the largest number?
700.
We can start with the 7. Say the whole thing.
7 and 800.
7 and 800 thousandths. 7 and 800 thousandths is the largest of those four numbers, and we'll write that down as 7.8 because that's the way it was before we added the zeros. And we can now cross it off our list, and we just have to look at these three at the end. 8, 780, and 700. Of these three numbers, read to me the full number for the largest one.
7 and 780 thousand.
Yes, and we'll just write 7.78, and we'll cross it off our list. And we only have 2 more left. Of these two numbers, which is the larger? Read me the entire number.
7 and 700 thousand.
And we'll just write 7.7, and that leaves the last one, the smallest one to write over here at the beginning of our list. And please read it to me.
7 and 8 thousandths.
Yes, and there'll be many times in your work with decimals that you might have a list of numbers and you need to put them in proper order, and this is how we do it. Now you have all your basic tools, and we're ready to add, subtract, multiply, and divide decimals. First, we're going to add. 58.4 plus 3.75 plus 0.078 plus 597.308. In order to add them, we have to rewrite it and line it up and down. And when we add decimals, the important thing is to line up the numbers so that each is in the right column and the right place. And we do that by making sure that the decimal points are in a line, one on top of the other. First we have 58 and 4/10. What's the next number?
3 75 hundredths.
3 and 75 hundredths. This 3 has to be in the ones column, and the decimal points are lined up. Read the next number.
78 thousandths.
We have the decimal points lined up, and that way it goes out to the thousandths place. And read for me the last number.
597 and 308 thousandths.
Yes, that was exactly right. Now we can go ahead and add them. 8 plus 8 is?
16.
Put down the 6, carry the 1. 5 plus 1 is?
6.
Plus 7 is?
13.
13. Put down the 3, carry the 1. 4 plus 1 is?
5.
Plus 7 is?
12.
Plus 3 is?
15.
Put down the 5, carry the 1. 1 plus 8 is?
9.
Plus 3 is?
12.
Plus 7,
19.
put down the 9, carry the 1. 1 plus 5 is?
6.
Plus 9,
15.
put down the 5, carry the 1. 1 plus 5 is?
6.
Is it finished?
No.
What have I forgotten to do?
Bring down the decimal point.
Yes, we must put the decimal point in the answer. Now please read for me the answer.
659 and 536 thousandths.
All right, we'll do one more just to make sure we've got it. $736.09 plus 74 plus 1.009 plus 0.934 equals what? So again, we have to rewrite the problem and make sure the numbers are properly lined up. Read me the first number.
736 and 9 hundredths.
And read me the second number.
74.
But Uncle Dan, there's no decimal point in that number, so how can we know how to line it up with the decimal points in a line if there's no decimal point there? What can we do with this number? Where would the decimal point be if there were one.
On the right.
On the right at the end of the number. Because 74 is 7 tens and 4 ones, and we'll put the decimal point in. Read the next number.
1,9,000,000.
And the last one.
934,000.
And you can see everything is perfectly lined up. 9 plus 4 is?
13.
Put down the 3, carry the 1. 1 plus 9 is?
10.
Plus 3,
13.
put down the 3, carry the 1. 1 plus 9,
10.
put down the 0, carry the 1. 1 plus 6,
7.
plus 4,
11.
7 plus 4 is 11. Plus 1,
12.
put down the 2, carry the 1. 1 plus 3,
4.
plus 7,
11.
put down the 1, carry the 1. And 7 plus 1.
8.
And I must make sure I have my decimal point in the answer. Please read the answer.
812 and 33 thousandths.
812 and 33 thousandths. So all that you need to know to add decimals is to make sure you properly line up the numbers and that the decimal points are one below another in a perfect straight line, and that each number is in its proper place and proper column. And now we're ready for subtracting decimals. Just like when adding decimals, you have to rewrite the problem and make sure that the decimal points are lined up and that each number is in its proper column. Please read me the first number.
58 and 437 thousandths.
And the second number.
9 and 84 hundredths.
And that's the way it looks. Then we say 7 take away nothing is?
7.
Now, if this empty place there bothers you, what could you put in there without changing the value of that number?
0.
A 0. Now, you don't have to put it in there in order to do the problem. You could just bring the 7 down, knowing that 7 take away nothing is 7. But if you want, you can put the 0 there. 3 take away 4.
Can't do.
The 4 becomes a,
3.
so this 3 can become a,
13.
13 take away 4 is,
9.
3 take away 8.
Can't do.
The 8 becomes a 7, so that this 3 becomes a,
13.
13 take away 8 is,
5.
and we'll put our decimal point in now. 7 take away 9.
Can't do.
The 5 becomes a,
4.
so that the 7 can become,
17.
17 take away 9 is,
8.
4 take away 0 is,
4.
and our answer is,
48 and 597 thousandths.
yes. And if you wish, you can draw your box and do the check, and I think you'll find out that we did get it right. So I won't bother with the check, but we will do another one. 64.2 minus 8.987 equals what? Read the first number for me.
64 and 2/10.
And read the second one.
8 and 987 thousandths.
This time, we cannot just bring down the 7. We have to realize that there is a 0 in this place. So when the bottom number, when you subtract, goes out further than the top one, you have to put in these zeros before you can subtract. 0 take away 7.
Can't do.
We have to borrow all the way over from the 2. The 2 becomes a
1.
so that the 0 can be
10.
then the 10 becomes
9.
so that the 0 becomes
10.
10 take away 7 is
3.
9 take away 8 is
1.
1 take away 9.
Can't do.
The 4 becomes a 3 so that the 1 can be
11.
11 take away 9 is
2.
3 take away 8.
Can't do.
The 6 becomes
5.
so that the 3 becomes
13.
13 take away 8.
5.
5 take away 0 is
5.
and that's all you have to know for subtracting decimals. Remember, when there are empty spaces in this top number, the number you're subtracting from, you will have to fill those decimal places with zeros before you can subtract.
Productions, Golden Age Productions, standing in the gap of your educational needs.